Hello everyone, welcome back again to my channel. Today we will be taking up the lessons for quarter for week 1 of this school year. The objectives are the following. Number 1, define the following measures of position: quartiles, deciles, and percentiles. And the other one is illustrate the following measures of position: quartiles, deciles, and percentiles. But before that, let us look back with the previous lesson on measures of central tendency. Remind that in statistics, the central tendency is a central value or a typical value for a distribution. It is occasionally called an average or just a center location or the center of the distribution. And the three common measures of central tendency are the mean, median, and mode. Again, when we say measures of central tendency, it is a quantitative representation of the set of data under investigation. So let's take up the mean. Mean is the most important, the most useful, and the most widely used measure of central tendency. It is the average of the data set. So let us have an example. Given this ungrouped data, take note when we say ungrouped data, this is the set of data, basically a list of numbers. So we have here a list of numbers containing 9, 6, 10, 10, 7. And how are we going to find the mean? You just simply add up all the given numbers. So we have here 9 plus 6 plus 10 plus 10 plus 7. So these are the numbers in the set, divided by 5 because we have here 5 numbers in the given list. So the result is 8.4, and this is the mean of the given data. Let us proceed to the median. Median is the middle value in a set of numbers. Example, given the list of numbers 9, 6, 10, 10, 7, first, you are going to arrange the data in ascending order or from least to greatest. So, in the given set, so the first number will be 6, followed by 7, 9, 10, and 10. So, the middlemost value is 9, and that is the median. Or you can also use the locator's formula, that is n plus 1 divided by 2, where n is the total number of observations. Here, we have 5 total number of observations, so n plus 1, so that's 5 plus 1, that's 6, divided by 2 is equal to 3. That means to say the median is the third number on the list. So 9 is the median. If you're going to observe the given list is an odd, what if it is an even? And if we arrange that from least to greatest, you will observe that we have two middlemost number here. You're just going to find its average. So 9 plus 10 divided by 2, that's equal to 19 over 2. So the median is 9.5. Next is the mode. Mode is the most frequently appearing number in the data set. So example again, if we have 9, 6, 10, 10, 7, so first, we're going to arrange that from least to greatest and then identify the repeated value in the given set and find its frequency. So we have here 10, 10, we have 2 10s, and 10 appears most frequent in the given set. So this is the mode of the given data set. Now let's proceed to our discussion, the measures of position. And what are measures of position? These are numerical measures that are used to describe the standing or location of an observation relative to the rest of the data. The most common measures of positions are quartiles, deciles, and percentiles. And what are quartiles? Quartiles are points that divide a ranked data into 4 equal parts. Take a look on the illustration. Each part is equal to 25%. So 25% here, another 25%, 25%, and the last part is 25%. Each set of data has 3 quartiles, namely first quartile, second quartile, and the third quartiles. What are first quartile? First quartile is a number such that at most 1/4 or 25% of the data are smaller in value than quartile 1, and at most 3/4 or 75% are larger. So this is our quartile 1, and to the left is 1/4 or 25% of the data, and to the right is the 75% of the data larger than quartile 1. First quartile, that is also named as lower quartile, or in symbol we can have Q sub 1 or Q1. Again, for the term ungrouped data, this is the set of data, basically a list of numbers that is not sorted into categories, classified, or grouped. And where can we find the first quartile? The first quartile is the n plus 1 all over 4 entry in the data set, where the variable n here is the number of observations in the data set. So example, consider the data set A is equal to the set of 14, 23, 19, 36, 25, 45, 39. Let us find the first quartile, or Q sub 1. Of course, our first step is we're going to list the data in increasing order. Now again, our given set of data is 14, 23, 19, 36, 25, 45, 39. The lowest number is 14, followed by 19, and then 23, 25, 36, 39, 45. Now, label the positions of the numbers if necessary. So we can write it this way. First number is 14, second, 19, third, 23, fourth, 25, fifth number, 36, sixth, 39, and seventh number in the list is 45. The next is we're going to compute for the location of the first quartile by using n plus 1 all over 4. Again, n is the number of observation. Now, let us compute for the location of the first quartile in the given data set by using n plus 1 all over 4. And since we have 7 number of observations, therefore the value of n is equal to 7. By substitution, that will become 7 plus 1 all over 4. And 7 plus 1 is equal to 8, divided by 4 is equal to 2. Take note that 2 here is not the value of the first quartile. It is the location or the position of the value of the first quartile in the given set of data. So, the second number in the list is 19. Therefore, 19 is the first quartile, which is exactly the second number in the list. Let's proceed to second quartile. What are second quartile? It is a number such that 1/2 or 50% of the data are below and above in value than quartile 2. So in our illustration here, this is the second quartile. On the left part, this is the 50% of the data lower than the second quartile. On the right side part, this is the 50% of the data which is above in value than the second quartile. Another term for second quartile is middle quartile or median, or we can have also Q2 or Q sub 2. For an ungrouped data, the second quartile is the 2 times the quantity n plus 1 all over 4 entry in the data set. For first quartile, we have only n plus 1 all over 4. But for second quartile, this time we will have 2 times the quantity n plus 1 all over 4. Again, n is the number of observations in the data set. Example, the same data, 14, 23, 19, 36, 25, 45, 39. Let us find the second quartile or the middle quartile or the median. Okay, let us again list the data in increasing order, same as what we have done a while ago. Then label the positions of the numbers if necessary. So we will have first number 14, second number 19, third 23, fourth 25, fifth 36, sixth 39, and seventh 45. Let us again compute for the second quartile by using 2 times the quantity n plus 1 all over 4 so that we can locate the second quartile. So computing for 2 times the quantity n plus 1 all over 4, and since we have n is equal to 7, by substitution, that will become 2 times the quantity 7 plus 1 all over 4. 7 plus 1 is 8 times 2, so that's 16. Divide by 4 is equal to 4. Again, 4 is not the value, but the location of the second quartile. So, 25 is the second quartile, which is exactly the fourth number in the list. Third quartile. This means it is a number such that at most 3/4 or 75% of the data are smaller in value than quartile 3, and at most 1/4 or 25% are larger. So we have here now the third quartile. So on the left side part, 25 plus 25 plus 25. So this is 75% of the data which is smaller in value than the third quartile. And on the right side part, which is only 1/4 or 25%, which is larger than quartile 3. Third quartile is also named as upper quartile, or we can have Q3 or Q sub 3 in symbols. Let us again have, for an ungrouped data, let us have 3 times the quantity n plus 1 all over 4 as the location of our third quartile in the data set. Again, n is the number of observations in the data set. Let us have example. Given the same set of data, let us find quartile 3. Again, list the data in increasing order. If necessary, label the positions of the numbers. So again, we have here our first number as 14 and the last number as 45. Using again 3 times the quantity n plus 1 all over 4, we can locate the position of the third quartile. And since we have n is equal to 7, by substitution, this will become 3 times the quantity 7 plus 1 all over 4. 7 plus 1 is 8 times 3, that becomes 24. Divide by 4 is equal to 6, meaning to say that is the sixth number in the list. Therefore, 39 is the third quartile, which is exactly the sixth number in the list. We have defined already the first quartile, the second quartile, and the third quartile. Take note again that Q2 is our middle quartile or the median of the data set. And the first quartile is the lower quartile and the median of the lower half of the data set, while the third quartile is the upper quartile and the median of the upper half of the data set. Let us have another term, the interquartile range or IQR. This is the difference between quartile 3 and quartile 1. So let's have again the data set, 14, 23, 19, 36, 25, 45, 39, which is our data set a while ago. Let us find its IQR. And since we have computed the value of the first quartile as 19 and the third quartile as 39, let us get its difference. So the IQR is 39 minus 19 is equal to 20. Now, let's proceed to the term deciles, which is another measure of position. These are 9 score points which divide a ranked data into 10 equal parts. So, what is the difference between quartiles and deciles? Quartiles, that's divided into 4 equal parts, and deciles into 10 equal parts. So observe the given illustration. For quartiles, we have 25% for each part, while decile, each part is 10%. And we have 9 score points, namely decile 1 or D1 up to D9 or decile 9. How are we going to compute for decile? So let's have this data set. C is equal to the set of 6, 9, 8, 4, 11, 9, 7, 2, 5, 14. Let us find decile 3. Of course, we will list down the data in increasing order. And if necessary, let us label their position. The lowest number in the data set is 2. That will be marked as the first number in the list. The second is 4. The third is 5. Fourth, 6. Fifth, 7. 6, 8. 7, 9. Eighth number in the list is 9. Ninth is 11. And 10th on the number is 14. So we have 10 observation in the given data set. Now, if we have used n plus 1 all over 4 for quartiles, and since we are computing for deciles, we will be using k times the quantity n plus 1 all over 10 because it's divided into 10 equal parts already. And k here will be the values of 1, 2, 3, up to 9 because the decile is being divided into 10 equal parts and we have 9 score points. N again is the number of observation. So let's compute for decile 3 by using k times the quantity n plus 1 all over 10. And since we're asked for decile 3, so our value of k is 3. And since we have 10 observations, so n is equal to 10. By substitution, that will become 3 times the quantity 10 plus 1 all over 10. And 10 plus 1 is 11 times 3, that's equal to 33. Divided by 10, that is equal to 3.3. This is not an exact value. So, that is between the third and fourth data. And what is the number on the third and fourth position? Those are 5 and 6. So, to be able to find the decile 3 or the value of the decile 3, we will be finding the average of the value on the third and fourth number. So, our third number is 5, the fourth number is 6, so 5 plus 6 is 11, divided by 2, therefore, our decile 3 is 5.5. Now, let's have percentiles. Percentiles are 99 score points which divide a ranked data into 100 equal parts. So take note for decile that is divided into 10 equal parts. For percentiles, it is divided into 100 equal parts. So if for quartiles, we have 25% for each part. And for decile is 10%. For how about for percentile? So it has 1% for each part. And we will have 99 score points for percentiles. Observe that D1 is the same as P10, or decile 1 is the same as percentile 10. Decile 2 or percentile 20. Decile 3 is the same as percentile 30. And between decile 2 and decile 3, or percentile 20 and percentile 30, we have the quartile 1. And D5 or P50 is the median or the second quartile. And D7 is the same as P70, D8 is the same as P80, and between D7 and D8 or P70 or P80, that is our third quartile. Now, how are we going to locate the position for percentile? So, we will be using k multiplied by n plus 1 all over 100. So, this is different from all over 4 for quartiles. And for decile, all over 10. And since the rank data is divided into 100 equal parts for percentile, so our denominator will be 100. Let us have example. Consider the data set C is equal to the set of 6, 9, 8, 4, 11, 9, 7, 2, 6, 14. Let us find percentile 60. Of course, we're going to list the data in increasing order. So, if necessary, let us label the position of the numbers. The lowest number in the list is 2. That will be our first number. The second is 4. The third is 6. The fourth number is 6. The fifth is 7. The sixth is 8. 7 is 9. 8 is 9. And the ninth is 11. And the 10th is 14. So there are 10 number of observations. To compute for percentile 60, we will be using k times n plus 1 all over 100. Again, for percentile, our denominator is 100. And the value of k is from 1 up to 99. Because for percentile, it has 99 score points. And again, n is the number of observation. So, let's compute for k times the quantity n plus 1 all over 100, which is percentile 60. So, our k is 60 and n is 10. 10 plus 1 is 11 times 60 all over 100. 60 times 11 is 660 over 100. That is equal to 6.6. So, the location of the percentile 60 is on the 6.6 position. This is not, again, an exact value. So, that is between the 6th and the 7th data. Therefore, we will be finding the average of the 6th and 7th data. The 6th number on the list is 8, and the 7th number on the list is 9. So, 8 plus 9 divided by 2. Therefore, the percentile 60 is 8.5. Thank you for watching and learning with me. See you on my next videos.